is March 13th, 2026, and this is Q4-12. Today we're doing area of a circle. So we're going to jump straight in. Professor Smart is teaching her students how the formula for the area of a circle was derived. Derived just means made from something else. So she takes a circle and cuts it into equal pieces and then rearranges them. So we can see that this has 8 pieces, and then these are the 1, 2, 3, 4, 5, 6, 7, 8 pieces put into a different form. It says, what general two-dimensional figure do you see when the pieces are rearranged? I know these are slightly curved, but if you just imagine a straight line up, over, and here, this is a parallelogram. And we can use a parallelogram to create the formula for area of a circle. To know that, we need to know what the formula is for the area of this shape. Okay, the area of that shape, or the area of a parallelogram, is the same as the rectangle. So we can write that as either area equals length times width, or area equals base times height. Either way, same thing. So we know that we have this shape, vaguely parallelogram, and we can use area equals length times width to figure out the area for the circle. But what is this length right here? We know that these dotted lines are the radius, because we can see that right here. Each one of these slightly curved lines shows up right here on the circle, okay? And I can see here that there are 4 at the bottom. And so if that accounts for 1, 2, 3, 4, it covers this. And so this whole length right here is half of the circumference. So we can write just down here, the length of the parallelogram is half of the circumference. This is important to know because when we fill this out, we know area equals length times width of a parallelogram. The width here is going to be r, and the length here is 1/2 the circumference, or 1/2 c. We know that we have a formula already for circumference. We learned on Wednesday. And the circumference formula, there are 2 of them, but because we have an r here, I'm going to use the version with the radius in it. And so the formula for circumference is 2 pi r. We still have this 1/2 of that in front, and we still have multiplying by r at the end. And we can combine some things now, because half of 2 is just 1. So these effectively cancel out. Pi can't be combined with anything, but we can take r times r and rewrite it as r squared, and that's it. This is our formula for area of a circle, and we just figured it out ourselves. So now we can use that to answer some questions. So let's move down a little bit. So area of a circle is the surface measurement. So how much space is inside the circle of a two-dimensional figure. So we use square units. And it is squared because area is always squared. It is something times something else. And in this case, we have r squared, so that helps us remember squared. We use the formula A equals pi r squared, where r squared is just equal to r times r, right? So radius times itself. So let's use that to answer some questions. This is very similar to how we did our circumference the other day. So in circle 1, we have this. It is shaded in. We're finding the area of the shaded part of the circle. We know the radius is 3 inches. So our formula is A equals pi r squared. And let's plug in our values. Remember, it doesn't say anything. We are using 3.14 for pi. So A equals 3.14. R is 3, and that squared goes on the outside of the parentheses. Now you can put this in exactly the same way that you see it here. So parentheses 3.14, parentheses 3, and then we have this squared button right here next to the 7, and when I press that, it adds a little squared there. And when I press enter, I see that my answer is 28.26. So area here is 28.26. My units are inches, and we add a little square there. And that's how you do that. Now, if you remember from Wednesday, we also have in terms of pi. In terms of pi means we want pi in our answer. And then we just need to figure out what r squared is. Well, r is 3, and 3 squared is 9. So my answer in terms of pi is 9 pi. So that's it. All right, if you want to pause here and work on 2 and 3 and then check your answers, you are more than welcome to do so, or you can follow along. So for number 2, we have this whole line is marked as 10. This is the diameter. So if the diameter is 10, then that means the radius is half of that, which is 5. So our formula is A equals pi r squared. Plug in our values. 3.14 times 5, and that's squared. Head over to my calculator. 3.14 times 5 squared is 78.5. And that is centimeters squared. And then in terms of pi, r squared, r is 5. 5 squared is 25, so 25 pi. Lovely. Last one. We have for this is marked here. That is the radius, so radius is 6. So formula is A equals pi r squared. Plug in values, 3.14 times 6 squared. Pop that in my calculator, and I should get 113.04 meters squared. And then in terms of pi, 6 squared is 36, so 36 pi. Pretty straightforward. Now, we do all of this so that we can actually answer questions, because more often than not, if you see this on the state test, it is going to actually be word problems like this. So let's jump into these and see what it is that they're asking us to do. So a circle has an area of 78.5 square inches. A couple of things to start off with. We don't have that circle. They didn't draw it. We don't really need to draw it. We do need to label that we know the area equals 78.5 square inches, can also be written as inches squared. It says, what is the radius of the circle? So radius equals what? That's what we don't know. Now we do have the formula that we can use. A equals pi r squared. A is 78.5. So that is equal to pi. We don't know r, so we're going to leave it as r, and squared. We need to divide by pi, and the value that we always use for pi is 3.14. So we're going to divide by 3.14 on both sides. And we're going to cross out pi and 3.14 are crossing out. No, they're not technically equal. We are using an approximation, so it works the same in this instance. So we're going to do 78.5 divided by 3.14, and that gives us 25. Now, 25 is not equal to the radius. It is equal to the radius after it has been squared. So what number do you multiply by itself to get to 25? It's the same way as taking the square root of 25. Now, if you need to do square root, it is right above the squared button. So you would hit second and the x squared button to get your little square root symbol in here. And then you would put 25, and that would give you the answer. Or you would tell yourself that you know that 5 squared is 25. So our radius is 5, and our unit is inches. There you go. This is how you take information that you've been given to solve. And in this case, we went a little bit backwards where we're given the area to solve for the radius. Now, I know that some of you are going to ask, is this always going to be a perfect square? For a 7th grade, yes, this is going to be a perfect square, or it's going to be a number that you will then be able to put into your calculator and do the square root of. All right, let's move on here. A circular sprinkler system is installed and waters an area of 28.26 yards squared. So we know area equals 28.26 yards is YD squared. What is the radius? So this is just like the last problem. So we're going to set it up exactly the same way. We know area is 28.26. I promise that's supposed to be a 6. I don't know what happened. Let's not talk about it. That is equal to pi r squared. And so we are going to divide again by our approximate of 3.14. So grab your calculators. 28.26 divided by 3.14. And it gives us 9. 9 is equal to r squared. And so the number that you square to get to 9 is 3. So the radius is 3 yards. Quick thing to remember, radius is singular units, area is squared units. Okay? Radius and diameter are singular units, just inches or just yards. And then area is inches squared, yards squared. All right, let's move on. This one's very important because you are going to have to do problems using this information in the future. So Jada says that if you are given the circumference of a circle, you have enough information to find the area of the circle. Is Jada correct? Why or why not? Jada is, in fact, correct. Yes, you can. And let's talk about why. The formula for circumference of a circle. There are 2 of them. But if we look at the one that has radius in it, circumference equals 2 pi r. And then you look at the formula for area of a circle, pi r squared. The thing that they have in common is radius. But that's not the only thing. They both contain radius, but that is also the only value that they contain together. That's the only letter. We are using a number for pi, 3.14, and then circumference is multiplied by 2, and the radius is squared for area, but the only value we need to know to plug in is the radius. So if I gave you a circumference, you would be able to go backwards to figure out what the radius is and then plug it into the area formula. So we're writing both formulas. They both contain radius and no other unknown value. So if you know one, you can figure out the other. And you will eventually be practicing how to do that, going from circumference to area or going from area to circumference, because you can go backwards. All right, last question we're going to do is number 4, and then we'll be finished. Let's just talk about this really quick. It says determine whether area or circumference is described by each statement below. This is important because on the state test, they're going to ask you a question similar to this, and you have to figure out which one you're supposed to be finding and then remember the formula for it. So A is the amount of fencing around a circular garden. Around. Think of a circle that you are going around. That is circumference. For B, the amount of frosting needed to cover a cookie. Imagine your cookie and you're covering it with frosting. cover is going to be area. So for C, the amount of crust needed to cover a pie, you are laying crust over the pie. Cover means area. And so in number 2 up here, our sprinkler system was watering a part of the yard, and so the water was covering the grass. And so that's why it was area. D, last one, the distance traveled in one lap around a circular track. If you're starting here and going all the way around, that around means circumference. All right, that's it. Hope you guys have a great weekend.